Hey there, everybody. This video is for lesson 4 in our current unit, unit 4. I will start off by saying that this lesson will be very similar to the previous lesson with side, and side angle, side, triangle congruence. So if you have not completed the lesson 3 or the lesson 3 assignment, you should probably do that before this lesson. Otherwise, some of this stuff might not make sense because we are going to go through this a little bit quicker than we did in the last lesson. So, lesson 4, this is all about angle, side, angle, and angle, angle, side, triangle congruence theorems. So again, these are just theorems that you can use that if you have limited information that you know about a triangle, you can use these theorems to prove that the triangles are the same. So that's what the objectives are, is to use angle, side, angle, and angle, angle, side to determine if the triangles are congruent. And then the second video, again, we're going to break this up to show that how to complete proofs with ASA and AAS congruency. Again, we are going to be using the reference sheet as basically to kind of take notes or to mark those little triangles. You should probably use the reference sheet at least for doing proofs too, but otherwise we're going to get started here. So again, we talked about this on the last lesson, where how do we know if two triangles are congruent if we only have limited information? So there are these various theorems that we can use. We have side, 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 angle, side. So we covered those in the last lesson, so those should be pretty apparent. And then angle, side, angle, and angle, angle, side. These are the two that we're going to focus on in this lesson. Again, these should be listed on the reference sheet. So as we go through these, you should follow along on your reference sheet and take any notes that you need to there. I would mark the triangles, how they're going to be marked as we go through these next two slides. So, angle, side, angle. That is when you know in two different triangles, you know that you have two angles that are the same. So this could be an example where we know that this angle is congruent to this angle because they have the same number of markings, one mark. And then these angles are the same because they have two arc marks. So we have our two angles are congruent. And then an included side. So basically, we talked about with side, angle, side, you have an included angle. An included side just means that they're talking the side that's between your two angles. So for angle, side, angle, or ASA, it would need to be this side right here in the bottom, because that's the side that's kind of between these two angles here. So again, that's what included means, between. The other one that we're looking at today is angle, angle, side. So that would be with two different angles that are congruent. So this time I'm going to do this other angle. So these angles are congruent in the bottom left, and then these angles are congruent. Again, the same number of arc marks tells you kind of which angles should be the same here, or the number of tick marks tells you which sides are the same. All right, so in this one, two angles and a side that's opposite them. So we have two angles that are congruent, or two pairs of angles, and a side opposite. Opposite just means it's not between, because if it was between, then it would be the ASA. So for AAS, we just need a side to be congruent to another side in these two triangles that's not between those two angles. So opposite just means not between here. And a lot of these, when you're going through them, you can kind of just say like angle, angle, side. So we have angle, angle, side. If I flip back to the last one, you should be able to see it's like angle, side, angle. Angle, side, angle. So that should be kind of a way to look at these congruence theorems as well. So this is also on your reference sheet. Excuse me. This is something that you would really use mainly for probably doing for the proof section. But it is also helpful just to kind of look at so you know why sides can be congruent. Again, they can be given to you with the little marks. Sides can be congruent if you know that something is a midpoint. Reflexive property is when you have a shared side, so if it's congruent to itself. Reason that angles are congruent, it's given to you. You have vertical angles, so when two lines intersect. And then these angles right here are what I think are giving people some trouble. We can only use these angles if you have parallel lines. So if you run into an issue where you don't have any parallel lines, you should automatically know that these three angle, alternate interior, alternate exterior corresponding angles, these are not going to show up anywhere because you need to have parallel lines. And then the definition of angle bisector, we can talk about that too. A bisector just means it cuts it like right in half. So if you have a line that's an angle bisector, it's going to cut an angle into two equal smaller angles. So we're just going to look at a few examples now. So example 1 says determine if the triangles are congruent by angle angle side or angle side angle, or if there's not enough information to say that they're congruent. So right away, I'll tell you how I approach these problems. You should be able to notice that we have these two angles are the same, these two angles are the same, and then this side is the same as that side. So we would have angle, angle, side, angle, angle, side. So that's the way that I would approach this. Again, those angles are congruent. Those angles are congruent there. And then finally, the pair of sides that we have are also basically shown to be congruent because that's what the one arc tick mark means there. So this would be angle, angle, side. So we could say, yes, the triangles are congruent by angle, angle, side, or AS. Example 2. So again, this would be a scenario where you can see that these two angles are the same here. That's what those marks mean. So that this angle on the left triangle is the same as this angle right here in the right triangle. Excuse me. And you can see that these two angles down here are the same. So we have angle, angle, and then over here, angle, angle. And then one thing that you need to be kind of looking out for as we go through this unit is whenever two triangles are kind of like smashed together like this is a common side here. So this side, if you pull these triangles apart, that side is going to be the same no matter what in both triangles. So it would be congruent in both triangles. So this would be an angle, side, angle problem. So again, those angles are congruent. These angles are congruent down here. And then this side is congruent to itself, but it's the shared side and it's between the angles. So it would be angle, this side, angle, or ASA. So we would say, yes, the triangles are congruent by ASA. All right, last example here. This is where it gets tricky. So this is where I think people are going to have the most trouble is when we bring in the parallel lines. So again, whenever you have parallel lines, you can look at your reference sheet. If you see parallel lines, we could probably use either those alternate interior, alternate exterior, corresponding angles, whatever. So that should just be kind of your clue that if you see these parallel marks, you're going to probably use those angles. All right, so here, they tell you that these two angles are the same. So you got one angle pair. They tell you that this side is the same to this side. So we got like an angle, side, and if we could prove that this angle is the same as this angle, then we would have angle, side, angle, angle, side, angle. So that should be kind of what you're looking for. Is maybe trying to see if we can show that these two angles are the same. The other thing that you could look for is if you have an angle side here, if these two angles, this angle right here and this angle right here in this triangle, if those two angles are the same, you would have angle, angle, side, angle, angle, side. Now, with the parallel lines, you have a parallel line cut by a transversal here. This would be your transversal that runs through these parallel lines. What it's going to mean, so again, those angles are congruent. What it's going to mean is that these angles right here, they're corresponding angles created by these parallel lines cut by this transversal. Corresponding angles have to be congruent. So these angles are going to be congruent because they're corresponding. So again, we would have angle, side, angle because they tell you that those two sides are congruent. So this would be angle, side, angle. Again, with these ones, you just have to make sure you're looking out for the parallel lines. This is something that should be a trigger that says, okay, parallel lines, corresponding angles, alternate interior angles, something, one of those things on your reference sheet that you could look at. So you should be able to complete problems 1 through 10 on the lesson 4 assignment. Now, 1 through 10 does include some side angle side and some side side side. So make sure you're not, just review those if you need to. Otherwise, just kind of ask me questions as you're working. After you finish those problems, go ahead and watch the second video about how to complete the proofs over these ASA and AAS congruency theorems, and then complete the rest of the assignment after that. All right, that's it for video 1.